Hello students, we continue with the chapter number 2, computer hardware. Today we are going to see about multiplexers in computer hardware. Multiplexers in computer hardware. Okay. So what is a multiplexer? Multiplexer is also a combinational logic circuit. It is used for selecting one input line from many input signals. So let me repeat again. It is used to select one of many input signals. So it is having many input signals. Out of that many input signals, it can select one particular input signal and produce only one output line. This multiplexer is also called a data selector. The reason why it is called a data selector, it is that this multiplexer having some selector lines. This selector lines helps the multiplexer to select the input, one input at a time, right? So a multiplexer contains many input lines. Out of that many input lines, it chooses one input at a time and produces one output signal. And in this page, what you are going to see, or what you are seeing, it is the block diagram of a multiplexer. Here you can see that left side, it is having many input lines, and we have the selector lines on the diagram, and this selector lines helps to choose one input signal at a time and it produces one output. Okay, here in this diagram you can see a 4-to-1 multiplexer. 4-to-1 multiplexer means this multiplexer is having 4 input lines and it can produce one output line, right? Okay, here you can see that I0, I1, I2, I3 are the 4 input lines and Y is the only one output line. S0 and S1 are the 2 selector lines. Okay. So, if you look into the 4-into-1 multiplexer, it looks quite similar to the, or we can say it is a modified version of a 2-to-4 decoder, right? 4-into-1 multiplexer, we can say it is a modified version of a, so 4-into-1 multiplexer is a modified version of a 2-to-4 decoder. In 2-to-4 decoder we have that 2 input signals, say S0 and S1, and its output are getting through the 4 AND gates. So here it is like we have some attached input lines, and those 2 lines S0 and S1 are the selector lines. Okay, we already know that in the case of a multiplexer, it is having many input lines. Here also we can see that it is having 4 input lines. Out of that 4 input line, which input line to be selected is decided by the selector lines. Okay, so here in this diagram you understand in such a way that when we can see that S0 is having 2 states, that is, one state is it's the normal form and its complement form. That is, normal form means it is 1 and complement form means it is 0, and NOT gate is connected, that is it's a complement form or the negated form. And S1 also having 2 states, 1 and 0, right? And you can see that the AND gate F0 is connected to S0 and S1. Let me repeat again. The AND gate F0 is connected to S0 equal to 0 and S1 is equal to 0. And the AND gate F1 is connected to S0 equal to 0 and S1 is equal to 1. And the gate F2 is connected to S0 is equal to 1 and S1 is equal to 0. And the gate F3 is connected to the selector line S0 equal to 1 and S1 is equal to 1. Okay. So the condition is that whenever S0 equal to 0 and S1 is equal to 0, then F0 will be enabled. Suppose S0 is equal to 1 and S1 is equal to 1, then the gate F3 will be enabled. Okay, here you can see the truth table of a 4x1 multiplexer. Actually, in this truth table, what we are representing, it is the combination of selector lines values, that is S0 and S1 values, and the in particular input line selected during different values of S0 and S1. So here you can see that when A0 is equal to 0 and S1 is equal to 0, I0, the input signal I0 will be selected. When S0 is equal to 0 and S1 is equal to 1, the input signal I1 will be selected. Similarly, for S0 is equal to 1 and S1 is equal to 0, I2 will be selected. And when S0 is equal to 1 and S1 is equal to 1, the input signal I3 will be selected. Okay. So here we are going to see an 8-to-1 multiplexer. So 8-to-1 multiplexer means 8 into 1 multiplexer means we have 8 input lines and only 1 output lines. Though this circuit is having 8 input lines, there are 3 selector lines A, B, C, which helps the circuit to select only 1 input at a time. So the A, B, C are the 3 selector lines which helps the multiplexer to choose only one input at a time and produce only one output line. Okay. So here you can see that the input lines are D0, D1, D2, D3, D4, D5, D6 and D7 are the 8 input lines. A, B and C are the selector lines. So for the value A is equal to 0, B is equal to 0 and C is equal to 0, the input selected is D0. Suppose you imagine when A is equal to 1 and B is equal to 1 and C is equal to 1, the input selected is D7. So take another case. Suppose A is equal to 0, B is equal to 0 and C is equal to 1. That is A is 0, B is 0 and C is equal to 1. That is 0, 0, 1, which can select the input line D1. So based on that input line D1, there will be a corresponding output. Suppose you imagine a case where A is equal to 1, B is equal to 1 and C is equal to 0, which is 1, 1, 0. That is A equal to 1, B is equal to 1 and C is equal to 0. So the selected input line is D6. So it can produce one output line based on the selected input line. Okay. Here you can see the truth table of a 8-into-1 multiplexer. So this truth table tells you about, based on the selector line values, which input will be selected at a time. When A is equal to 0, B is equal to 0, you can see that. C is equal to 0, you can see that the input line D0 will be selected. And similarly, you can see that when the D1 input line gets selected, when A equal to 0, B equal to 0, C equal to 1, the D1 input line gets selected. And similarly, you take the case of D7. The D7 input line will be selected when A is equal to 1, B is equal to 1 and C is equal to 1. Okay. Okay, now we are going to see the applications of a multiplexer. So the multiplexer is used whenever we want to use the selection in electronic devices. So multiplexer is used in TV remote, parallel to serial conversion, and in all the electronics devices where we have to choose from many input signals. Okay, so it is a data selector. It helps to choose one input signal from many input signals. Okay.